What is speculative sampling? In DeepMind's paper, Accelerating Large Language Model Decoding with Speculative Sampling, the research team proposed an algorithm that achieves 2.5 times decoding speedups on a 70 billion large language model. This speedup algorithm maintains high sampling quality and does not require any modification to model architecture. So how does this algorithm work? Assume we have a large language model, and now we want to sample the next token from a distribution Q. We want to know the values of Q at different points. But Q is from a large language model, so sample Q is quite expensive. So we want to sample from a cheaper proxy of Q instead. Although P is cheaper, the distribution of P is not equal to Q. So how can we sample from P and get the result exactly equal to those sampled from Q? We may understand speculative sampling from the following equation. Take the minimum of P and Q and add the maximum value between 0 and the difference of Q minus P, and you will find the result of combination is equal to Q exactly. The minimum part is shown in the yellow area of the figure, and the green area represents the maximum part. If we can find an algorithm estimating the green part and the yellow part exactly, and most of the time only P is sampled, we can significantly reduce inference cost because we sample from a small model rather than an expensive one. In this algorithm, we will first sample from P and check whether this sample result is acceptable. The probability of acceptance is the minimum of 1 and the ratio of Q to P. So if Q larger than P, then the result is accepted. If the value of P is larger than its of Q, then we will accept the result by the ratio of Q to P. With these operations, we can see that we are exactly sampling from the yellow part. If the first sample is rejected, we will get one new sample from the normalized of the positive parts of Q minus P. Normalized positive Q minus P is equal to this term in the equation. And we multiply this term with the probability of rejection, and we will see the result will be equal to the maximum of 0 and Q minus P. This is how speculative sampling works.